Hello, everyone. So last time we were looking at the chain rule. So it's a very important rule for differentiation, chain rule. So we saw different notations for chain rule. We saw that, you can write it as f of g of x, derivative equals g prime of x times f prime of g of x. So this is one way to state the chain rule. Or you can write it as f of u derivative is equal to u prime times f prime of u. Or you can write it as dy to dx equals dy to du times du to dx, where u is equal to, or sorry, y is equal to f of u. So all three notations are important and different implications. So depending on the context and the example and the type of function, we can choose one of them to work with. Okay, we saw some applications of chain rule. Applications of chain rule. So for example, we saw ln u derivative equals u prime over u, where u is equal to some function again. So basically chain rule says that, for example, we know ln x derivative is 1 over x. Now ln u derivative, if you replace x with u, what you need to do is that you have to still do the standard differentiation. So if it was ln x, you would say 1 over x, right? So ln u, you would say 1 over u. But then you have to multiply it with u prime. So that's the only important thing in chain rule, that just a standard derivative that you would say if you had x instead of u, what would be the answer? But then just please remember to multiply it with u prime. So ln u is derivative is 1 over u times u prime, or in other words, u prime over u. Now more applications. Let's say if y is equal to e to the u, then what is dy to dx? In other words, what is e to the u derivative? So dy to dx, so by chain rule, we know that dy to dx is equal to dy to du times du to dx. So that means e to the u, or dy to dx, e to the u derivative, which can be also written as dy to dx, is equal to derivative of e to the u respect to u is e to the u times du to dx means times u prime. So we showed that e to the u derivative is u prime times e to the u. Again, see, similar to before. E to the x derivative is e to the x. Now, e to the u derivative, you would say e to the u. But then you have, by chain rule, you have to multiply it with u prime. So multiplying with u prime is the most important thing that you have to remember. We will see that we will have the same similar rule, for example, for sine u. For example, we know that sine x derivative is cos x. So sine u derivative will be cos u, but then multiply it with u prime. So the rule is very simple. No matter what the function is it exponential, trigonometric, logarithmic, just differentiate as if you had x there, but then you have to multiply it with u prime at the end. Just multiply with u prime at the end. So let's look at an example for this. Let's say y equals e to the 3x. Find dy to dx, which can be also written as y prime. So y prime or dy to dx, according to the chain rule, by formula above, we can write this as 3x derivative times e to power 3x. E to power u derivative is u prime times e to the u. So u is 3x here. So 3x derivative times e to the 3x. 3x derivative is 3. So the answer is 3 times e to the 3x. Well, that's it. Or another example, let's say y goes e to the x squared. Find dy to dx. So again, dy to dx is equal to x squared derivative times e to the x squared. X squared derivative is 2x. So 2x e to the x squared. Another example. Let a bigger than 0, a not equal to 1. And let's say f of x equals a to power x. Find f prime of x. So for example, a could be 2. A is a positive number not equal to 1. For example, it could be 2. For example, what is the derivative of 2 to power x? Or it could be 3. What is the derivative of 3 to power x? We know derivative of e to power x. We know derivative of e to power x is e to power x itself. But what about 2 to power x or 3 to power x? What is the derivative of these functions? Now, how can I use chain rule to find this derivative? Well, we know derivative of e to the x, and we also know derivative of e to the u. So if I can write f of x as e to some power, then that would be great. Then I can find the derivative. So do you think we can write a to power x as e to some power? So solution, since we have a formula for e to power u derivative, we will first write a to power x in the form e to power u. So e to power, so a to power x is equal to e to power ln a to power x. Because we have a formula t equals e to power ln t. T is always e to power ln t, right? This is a formula you study pre-calculus or math 100. I think we, in the review lecture, first lecture, I also mentioned this formula. T is equal to e to power ln t for t bigger than 0. So this one, we can write it as e to power x times ln a. because ln a to power x, we can write it as x times ln a. Okay, there you are. We wrote a to power x as e to some power u. What is u here then? U is x times ln a. So what did we want to find? We wanted to find derivative of a to power x, which is going to be derivative of e to power x times ln a. Now, again, remember the formula that we had for e to power u derivative was u prime times e to power u. So this one we can write it as x times ln a derivative times e to power x times ln a. Now x times ln a derivative, ln a is a constant. So what is derivative of x times ln a? For example, what is derivative of 5x? It's 5. What is derivative of 6x? It's 6. What is derivative of ln a times x? It's ln a, because ln a is a constant. So this is ln a times e to power x times ln a. And again, e to power x times ln a, we know that it's a to power x, right? We had the formula here. E to power x times ln a is a to power x. So this one we can write it as ln a times a to power x. So we showed that a to power x derivative is equal to ln a times a to power x itself. And this formula is consistent with the formula we had for e to power x derivative, because this a potentially could be e itself, right? So if you replace a with e, this formula says e to power x derivative equals ln e times e to the x, but ln e is 1. 1 times e to the x means e to the x. So e to the x derivative is equal to e to the x, which is the formula that we already knew from before. So what I'm saying is that this formula is consistent with the formula that we had for e to the x. If you replace a with e, again, you will have e to the x derivative equals e to the x, which is the fact that we already knew about. Okay. Now, for example, y equals 2 to power x, find dy to dx. So dy to dx equals 2 to power x derivative. According to this formula is ln2 times 2 to power x. Another example, again, y equals this time 2 to power x squared. Find d squared y to dx squared. So d squared y to dx squared is a notation, is Leibniz notation for the second derivative of y. How can I find the second derivative of y? First, I need to find the first derivative of y, and then differentiate one more time to find the second derivative of y. So what is the first derivative of y? So y prime equals dy to dx equals 2 to power x squared derivative. So that is x. So what is it? 2 to power x squared derivative. We had a formula for 2 to power x derivative, which is ln 2 times 2 to power x. So what is derivative of 2 to power u? because this is some function of the form 2 to power u, right? So what will be the formula for derivative of 2 to power u? So by chain rule, 2 to power u derivative is equal to ln2 times 2 to power u, right? See, 2 to power x derivative is ln2 times 2 to power x. So 2 to power u derivative is ln2 times 2 to power u, but then we have to multiply it by u prime. So maybe this sentence is the most important sentence in this whole Calculus 1 course. That if you replace x with u, where u is a function of x, in a function, and you want to differentiate, so you would differentiate in a way that, just in a way that you would have x. What would be the derivative? Just replace x with u. But then at the end, you have to multiply it with u prime. So this multiplying with u prime, which is implied by chain rule, I can say maybe it's the most important fact in this whole course. Okay, so 2 to power x derivative is ln2 times 2 to power x. Therefore, 2 to power u derivative is ln2 times 2 to power u times u prime. So here u is x squared. So I can say this is derivative of this function is ln2 times 2 to power x squared times x squared derivative. X squared derivative is 2x. So this is 2x ln2 times 2 to power x squared. Okay, so this is a derivative of y. Now, what will be the second derivative of y? We want to find a second derivative of y. So to find y double prime equals d squared y to dx squared, differentiate y prime once more. So d squared y to dx squared is equal to d to dx of 2x ln2 times 2 to power x squared. So 2 ln2 is a constant. I can take it out. Now for the function that is left, x times 2 to power x squared. Which derivative rule should I use? The 2 times ln2 is a constant. I can take it out. Then x times 2 to power x squared will be left. Which derivative rule should I use for x times 2 to power x squared? I have to use the product rule, right? Because it's a product of two functions, x and 2 to power x squared. X times 2 to power x squared, the derivative can be found using the product rule. So then I can say it's x times 2 to power x squared derivative. And then this is 2 ln2. Now derivative of the function inside, it's going to be, like I said, we have to use product rule. So x derivative times 2 to power x squared plus x times 2 to power x squared derivative. The answer is 2 ln2. Derivative of x is 1. So 1 times 2 to power x squared plus x times 2 to power x squared derivative. We just calculated here, right? What was it? 2 to power x squared derivative is this guy here. 2x ln2 times 2 to power x squared. We already calculated the derivative of 2 to power x squared. And that's exactly what we need here. So times 2x ln2 times 2 to power x squared. So I can take 2 to power x squared also out, right? It's a common factor. I can take it out. So it's going to be 2 ln2 times 2 to power x squared times 1 plus 2x squared ln 2. That's it. This is the formula for d squared y to dx squared, the second derivative of y. Add part B for the function above. Find, let's say, f double prime of 1. So f double prime of x is the second derivative that is given here. So this is 2 ln 2, 2 to power x squared times 1 plus 2x squared ln 2. Okay, so when you want to find f double prime of 1, f double prime of a fixed number, first you need to find f double prime of x. First you need to find f double prime of x, then replace x with 1. Same thing for the first derivative. I remember this is a common mistake in the previous semesters I was teaching this course. In the exam, some people make this mistake. Even for the first derivative, let's say some f of x is given and f prime of 1 is asked. F of x is given, f prime of 1 is asked. Some people, first they replace x with 1, then they get f of 1, and then f of 1 is a constant, right? And then they think the derivative of the constant is 0, so f prime of 1 is 0. That's not true. That's a wrong approach. When they ask about f prime of 1, you have to first find f prime of x, because f prime of 1 means what? Means f prime of x as a function. F prime of x is a function. We saw that we can look at it as a function. F prime of x, which is a function evaluated at x equals 1. Okay, so to find f prime of 1, first you need to find f prime of x. You will get the formula in terms of x, then replace x with 1. Same thing or similar thing for f double prime of 1. F double prime of 1, how should you calculate it? First, you need to find f double prime of x. You will have a formula in terms of x, then replace x with 1. So f double prime of x, or d squared y to the x squared, we already calculated here. So we just need to replace x with 1. In Leibniz notation, if you want to write it, you can also do it this way: d squared y to dx squared at x equals 1. Okay, so this vertical line means at, which has the same meaning as f double prime of 1. F double prime of 1 also means f double prime of x as a function evaluated at x equals 1. This one also means d squared y to dx squared as a function evaluated at x equals 1, and these two are the same concept. Okay, they represent the same quantity. F double prime of x evaluated at x equals 1. So then this is equal to 2 ln 2 times 2 to power 1 squared times 1 plus 2 times 1 squared ln 2. So this is 4 ln 2 times 1 plus 2 ln 2. So this is f double prime of 1. Okay, so we calculated derivative of e to the x, then e to the u, then a to the x, and also a to the u. Derivative of a to the u, we also calculated as an example of that. We calculate derivative of 2 to power x squared, and also the second derivative of 2 to power x squared. All right, now let's look at more applications for chain rule. So this one we can call it application 1. This one we can call it 2, derivative of e to the u. Now third one, let's say for trigonometric. Let's say sine u, y equals sine u. Then let's say if you want to find y prime equals dy to dx. Again, you can guess what the answer should be, right? We explained that chain rule says that, if you replace x with u, just do the differentiation as if you had x. But sine x derivative is cos x. So is it safe to say sine u derivative is cos u? Almost. Why almost? Because then you have to, yes, cos u, but then multiply it with u prime. Chain rule says you have to multiply it with u prime at the end. So dy to dx is equal to, so you can say by chain rule, dy to dx equals dy to du times du to dx. And then this is cos u times u prime. So we showed that sine u derivative is equal to u prime times cos u. Similarly, for the other functions, other trigonometric functions, similarly, cos u derivative is equal to u prime times minus sine u, because cos x derivative is minus sine x. So can I say cos u derivative is minus sine u? Almost, but I have to also multiply it with u prime. So the answer will be minus u prime times sine u. Similarly for tan u derivative, what was tan x derivative? Secant squared x. So tan u derivative is secant squared u times u prime. So u prime times secant squared u. Or similarly for cot u minus u prime times cosecant squared u. Because cot x derivative is minus cosecant squared x. So cot u derivative is minus cosecant squared u times u prime. So let's look at an example. Let y equals sine 2x squared plus 1. Find dy to dx. So dy to dx, or in other words, y prime, is, so we have a function of the form sine u. Sine u derivative is, we just said u prime times cos u. So u is 2x squared plus 1, so 2x squared plus 1. Derivative times cos 2x squared plus 1. And the answer is 4x times cos 2x squared plus 1. Another example, let y equals sine 2x. Find y prime equals dy to dx. Part A, using the chain rule. Part B, using the product rule. So for part A, again, y prime equals dy to dx. Again, we have a formula for sine u derivative. What is sine u derivative? It's u prime times cos u. So then this is 2x derivative times cos 2x. And then the answer will be 2 times cos 2x. Now, what about using the product rule, part B? So first we have to write y as a product of two functions. Right now, y is sine 2x, which is not written as a product of two functions, but I can write it as product of two functions. I just need to use the formula for the double angle formula, the formula for sine 2x, which is 2 sine x cos x. So then this is a sine 2x equals 2 sine x cos x. And therefore y prime, or dy to dx, is equal to, now I have to use the product rule, so it's going to be 2 times, for this one, product rule says what? uv, okay, it seems that the screen is freezed. Okay, I can stop. Okay, here. Yeah. So part A, we were asking to find y prime using the chain rule. Part B using the product rule. Now for chain rule, we said that sine u derivative is u prime times cos u, and u is 2x. So 2x derivative times cos 2x, which is 2 cos 2x. Part B, we said, in order to apply product rule, first we need to write y as a product of two functions. Which two functions? Well, sine 2x is 2 sine x cos x. Therefore, y prime. Now for y prime, I have to use the formula for derivative of uv. What is the derivative of uv? uv derivative is u prime v plus uv prime. So sine x derivative times cos x plus sine x times cos x derivative. And now this is 2 times cos x times cos x minus sine x times sine x. Sine x derivative is cos x derivative is minus sine x, so we can substitute them here. So then 2 times cos squared x minus sine squared x. Cos squared x minus sine squared x is cos 2x, so this is 2 times cos 2x. Which is the same answer we got using part A using the chain rule. All right, so let's look at the next example. Okay, example, find d to dx of sine of root 1 plus cos x. Okay, we want to find the derivative of this function. What is the function? Sine, see, it's not sine x times this, okay? It's sine of, the expression inside sine is root 1 plus cos x. So sine of root 1 plus cos x. So what is the derivative of this function? So d to dx of sine of root 1 plus cos x. But just use the formula for sine u. What is the sine u derivative? Sine u derivative is equal to u prime times cos u. So then this is equal to root 1 plus cos x derivative times cos root 1 plus cos x. Sine u derivative is u prime times cos u. So this guy derivative times cos u. And then what is that going to be? Derivative of root 1 plus cos x. What is it? Which formula should I use? See, root 1 plus cos x. It's root of some function, right? So it's a function of the formless. If I call 1 plus cos x as v, it's a function of the form v to power 1/2 or square root v. Right? Now, what is the derivative of square root v? This one we also saw last time using the chain rule, right? Derivative of a function of the form v to power, it's a v to power 1/2. Square root v means v to power 1/2. V to power 1/2 derivative is 1/2 v prime times v to power 1/2 minus 1, which is 1/2 v prime v to power minus 1/2. V to power m derivative is m v prime v to power m minus 1. See, again, it's just the application of chain rule, because chain rule says, x to power m derivative is m x to power m minus 1. So what is v to power m derivative? M v to power m minus 1. Then multiply it with v prime. So m v prime v to power m minus 1. And what is v here? V is 1 plus cos x, right? Because I have my expression is 1 plus cos x to power 1/2. So my v is 1 plus cos x. So let me replace the first derivative here, this derivative here. Let me replace it with 1/2 times 1 plus cos x derivative times 1 plus cos x to power minus 1/2. Then times cos root 1 plus cos x. Now, what is this? Cos x derivative is minus sine x. So minus sine x divided by, now power minus 1/2 means 1 over root of the function, right? So it's going to be 2 root 1 over 2 root 1 plus cos x. Power minus 1/2 means 1 over root. So minus sine x over 2 root 1 plus cos x times cos root 1 plus cos x. So let me add part B for the function above. Find, let's say, f prime of 0, or f prime of, f prime of 0 and f prime of pi half. So f prime of 0 means what? So this is f prime of x. This is f prime of x. I just need to evaluate this function at x equals 0, meaning that I just need to replace x with 0. F prime of 0 means f prime of x. Just evaluate at x equals 0. So then just replace x with 0 here. So minus sine 0 divided by 2 root 1 plus cos 0. Cos 0 is 1. And cos root 1 plus 1. So this is minus 0 times cos root 2 divided by 2 root 2. So 0 times anything is 0. The answer is 0. And then f prime of pi half, again, means f prime of x times x equal, and at evaluated at x equals pi half, not times, at evaluated at x equals pi half. Then the answer is minus sine pi half divided by 2 root 1 plus cos pi half times cos root 1 plus cos pi half. Then the answer is minus 1 times cos 1 divided by 2, which is minus cos 1 divided by 2. So minus cos 1, how much is the value of cos 1? Well, here the angles are in radians, right? So cos 1 means 1 radian. How much is 1 radian? Well, we know that pi radian is 180 degrees. So if you want to know 1 radian, you can calculate it that way. And you will see like 1 radian is almost, 57 degrees. So cos of 1 radian, which is almost 57 degrees, you can calculate it. You have to use calculator because it's not in our table. And then minus that number divided by 2, that will be the value of f prime of pi half. So I can add part C, for example, that let's say if you want to find the equation of tangent line, at x equals pi half. So what is the equation of tangent line at x equals pi half? We know that the equation of tangent line, equation of the line will be y minus f of pi half equals f prime of pi half times x minus pi half. Right? At x equals pi half means y minus y naught equals m times x minus x naught. M, the slope is of course f derivative at pi half, x naught is pi half, and y naught is f of pi half. How much is f of pi half? We have to, what was f of x? F of x was sine root 1 plus cos x. Sine root 1 plus cos x. So f of pi half will be sine root 2. Sine root 2. Again, if you want to calculate sine root 2, you have to use the calculator, but please make sure you use radian. Root 2, you have to calculate radian, and then calculate sine root 2. And then y minus sine root 2 equals minus cos 1 divided by 2 times x minus pi half. So this is the equation of tangent line at x equals pi half. Okay, guys.